Good morning, good afternoon, good evening, depending on when you're watching this. It's your boy Mr. Malachi and I'm back with another video, and in this video we're going to talk about these quadratic equations. And what are quadratic equations? These are equations that have two solutions, right? We're going to be getting two solutions coming out of them. Either x is equal to one value or that x is equal to another value. The standard form that we want to see these equations in is ax squared plus bx plus c is equal to 0. This is called the standard form, and what that basically means is that whenever we get these type of equations, we're going to put them in this form where the ax squared or the x squared term comes first, the one with the x comes next, and then lastly our constant comes last. And the rule we're going to be applying to solve these is that if a times b is giving me 0, then either the a is equal to 0 or the b is equal to 0. So this is a rule that we're going to be applying to help us solve some of these. Alright, let's look at an example. Alrighty, so in example 1, we're given x plus 2 multiplied by x minus 5 is equal to 0. So one thing I need to realize is that these two brackets are multiplying each other. So what does that mean? It means I could just take the first bracket, the x plus 2, which is my a, and make that equal to 0, or the second bracket will be equal to a 0. And in each of these brackets I could just solve for x quite easily. I take the 2 over and I change the sign of the 2, and so x is equal to negative 2 there. And in this next guy I take the negative 5 over and I change the sign, and that one x is equal to a positive 5. So that's how I would go about solving this. Again, one of those solutions work at a time. So what does that mean? I can take negative 2 and substitute it for x in there, and it will make this equation true. Or I could take positive 5, substitute it for x there, and it will still make this equation true. So that's what I mean by it having two solutions, but one of them works at a time, not both of them at the same time. So example 2 looks like this. What if we have an x that is multiplying a 2x minus 1, and this is also equal to 0? So this is still the same rule. I could just take the first guy, the x, and take that as my a, and so x is equal to 0, or the negative 2x and make that equal to 0. Then in this one, I don't really need to solve anything. X is equal to 0. That is the complete equation there. It's the complete solution. With this one, I do need to take the 1 over, making it a positive, divide by 2 there, divide by 2 there, and so x is equal to a half. And there we go. That's how you're going to solve for equation 2. Let's look at equation 3. Let's look at example 3. Alright, so for example 3, it's given that x squared minus 16 is equal to 0. So what you would have noticed is that in the previous two examples, these examples here were actually factorized for us. So the fact that I was getting two things that are multiplying and the answer was 0 means these were initially a trinomial. This wasn't initially a trinomial. This was initially maybe a common factor type of equation there. And it was factorized for us, and this is what we started off with, right? I hope that makes sense. This was something that was already factorized. But example 3 needs us to factorize it. So we need to now make those two brackets. And how do you factorize a difference of two squares? You just make two brackets, and then you square root your first term, and that will give you an x. That x goes into the first position of both brackets, then you'd come and you would square root the 16 and you'd get a 4. That 4 would go into the second position of both brackets. One is positive and one is negative. Then now that I have two things that are multiplying, this is my A and this is my B, and A times B is giving me a 0. I could just take the first bracket without the brackets, obviously, x plus 4, make that equal to 0, or the second bracket is equal to 0. And then if you solve for x in the first one, this is a negative 4, just took it over, the sign changed. And the second one, this would be a positive 4, and those are my final two answers. So that's how example 3 goes. Let's look at number 4, which also includes a difference of 2 squares. So how do I see that as a difference of 2 squares? It's quite hard to see it right now, but if you bring the 1 over, you should be able to see it. 9x squared minus a 1 would give me equal to 0, right? So all I just did was just bring the 1 over and change the sign. And now we can clearly see that's a difference of 2 squares. Let's factorize the difference of 2 squares. What did I do? I just square root this guy. When you square root that guy, it's just like square rooting the 9 by itself, getting me a 3, and square rooting the x squared by itself, giving me an x. And you just put these guys together, which will give me a 3x. So the 3x goes there and there. Then if you square root a 1, you'll get a 1, and that 1 goes there, and another 1 goes there. 1 is positive and 1 is negative. So now that I have my two guys, I take a 3x plus 1 is equal to 0, the first bracket, and I take the second bracket and I make that equal to 0. So even though I'm writing all here, I'm actually taking both brackets. So don't just solve for one of them, solve for both, just put an or there in between. This one goes over, it becomes a negative 1, and then I divide by 3, I divide by 3, and so x is actually a negative 1 over 3 as one of my solutions there. If I take this one over, I get a positive 1 there, divide by 3, divide by 3, and so this one, x is equal to a third. And there we go. These are our two solutions of x for number 4. Let's look at equation example number 5. So in example number 5, we're given this expression here, but again, what we need to do is we need to put it in standard form. So what I would do is I would take the 5 over, the 5x over, and if it goes over, it becomes a negative 5x, which is equal to 0. And now that I have it in standard form, yes, there might not be a c value there that is adding or subtracting, and that's fine as long as we have it in standard form, which means just bring everything onto one side. Then at this point, I can factorize that. What do I notice? I notice that I can take out x as a highest common factor. So if I take out x as the highest common factor, I'm left with the 2x there, which is subtracting a 5. Then I can take the first term, the x, and make it equal to a 0, or take the bracket, the 2x minus 5, and make that equal to 0. This is solved for x. I don't need to do anything there. This I do need to take the 5 over, making me a positive. Divide by 2, divide by 2, and so x is a 5 over a 2. And there we go. Very easy. So this one involved a little bit of highest common factor. So let's look at another one that involves highest common factor. 5x squared minus 8x is equal to 0. So again, this is also common factor, and what am I taking out in this case? I am taking out x again, and I'm left with these brackets. X times a 5x would give me back to a 5x squared. X times a negative 8 would give me back to that negative x at the top. Then again, I take my first term, make that equal to a 0, and I take the bracket, which is a 5x minus 8, and I make that equal to 0. Take the 8 over, it's a positive, divide by 5, divide by 5, and so x is actually 8 over 5. And there we go. Those are our 2x values. So let's look at a couple of more examples. Maybe let's look at ones that involve trinomials. Alrighty, let's try number 7. So this one includes, it's a trinomial. How do I know it's a trinomial? It has 3 terms. And so what we need to do is we need to be able to solve, or rather factorize that trinomial. So how do we factorize trinomials? Remember, we open our 2 brackets. Again, please check out the video on factorizing trinomials to see exactly what I'm going to be talking about now. So what we do is we square root this term, and that will give me an x, and that x goes into the first position of both brackets. Then I take the constant and look for the factors of the constant term, and in this case the 2 numbers that multiply to give me a 2 is a 1 and a 2. But those are not the only ones. There's also a negative 1 and a negative 2. So you shouldn't forget the negative ones. And now I'm checking to see which ones add to give me a negative 3. That is the coefficient of the x. So the top one gives me a positive 3. The bottom one gives me a negative 3. So those are the factors that I want to put inside of my bracket. A negative 1 there and a negative 2 in the second bracket. So now that I've established what my factors are and I've gotten my 2 brackets, I can therefore use that rule that we started with that just says take the first bracket, make it equal to 0, and take the second bracket and make that equal to 0. And so x in the second one is a positive 2, and x in the first one is a positive 1. And there we go. Let's try number 8. So number 8 looks like this. Alright, so this is also a trinomial. Again, how? Because it has 3 terms. And so I need to solve it like a trinomial. I need to factorize it like a trinomial. But this is not very easy, as clear cut as this one. This is an easy trinomial, I would say. This is a complex trinomial. So again, check out my video because I do 3 types of trinomial: easy ones, intermediate, and complex ones. And this falls under that bracket there. So how do we solve these complex ones? We just take the 3 there and we multiply it across to the 8. So the 3 is going to multiply the 8 and it goes away from that x squared. If it goes away, the 3 times the 8 is a negative 24. And we end up getting something that looks like that. Then at this point, we could just easily factorize that guy. Shouldn't be a problem. Factors of negative 24 that add to give me that is a negative 6 with a positive 4. So those are the factors of negative 24 that give you a negative 2. But just as much as I multiplied with that 3, I need to come back and divide with that 3 to make things right. And I divide these factors there with the 3. The one in the first bracket is going to simplify into an x minus a 2 because 6 divided by 3 is a 2. The one in the second bracket does not simplify. It stays as a positive 4 over 3. So now I can now use my rule, which says x minus 2 is equal to 0, or x plus 4 over 3 is equal to 0. And so x is equal to 2, and here x is equal to negative 4 over 3. And there's your two x values, 2 and negative 4 over 3. I hope that makes sense. I do want to do one more example, which is slightly different from the ones we've looked at. And this one looks like that. A minus 7 in the first bracket, a plus 3 in the second bracket, all equal to 24. So remember how this conversation started in the beginning. I said if you had two brackets that are multiplying and they're giving you 0, then you could just take the first bracket, make it equal to 0, take the second bracket, make it equal to 0. So it works, but only if this guy is a 0. If that guy is not a 0, you can't just say a minus 7 is equal to 24 and then a plus 3 is equal to 24 and solve for those. It does not work. This will be totally incorrect. But what you can do though, what would be correct, is to multiply out those brackets. So you FOIL them. A times a is an a squared. A times a 3 is a 3a. Negative 7 times a is a negative 7a. Negative 7 times a 3 is a negative 21. So that's the best way to do this. To multiply out those brackets. And what you will notice is that this guy and this guy are like terms. So if you subtract those like terms, you get a negative 4a minus 21 with the 24 on that side. Then what am I doing? I'm going to then therefore bring the 24 over. Remember, standard form, we want to see everything on one side of the equation. And so a squared minus 4a minus 21 minus 24 is equal to 0. Then those last two terms are like terms that would subtract each other and give me a negative 45. Then now that I've gotten there, I just make my two brackets, right? Factors of negative 45 that add to give me a positive, or rather, sorry, a negative 4 will be a negative 9 with a positive 5. So those are my factors. This is always an a or an x. And so the first bracket is a minus 9, which is equal to 0. And then a plus 5 is equal to 0. Then if you solve for a in each of them, a is equal to positive 9 for that guy, and here a is equal to negative 5. And there we go. So this is how you go about solving these quadratic equations. I hope you followed through with the video. I'll see you in the next video. Bye.